In this video, we're going to learn about the concept of momentum. But before we get on to that, let's think about this. If you had to stop one of these two men running, who would it be harder to stop and why? On the left, we have David Beckham running at you, and on the right, we have a large Peter Griffin-looking man running at you. Now, who would it be harder to stop and why? So obviously, the man on the right will be far more difficult to stop. But why? If you need it, take a few minutes and pause the video to think about it. Now, when answering this question, it's really important to think about the language you're using. And the correct answer is that he has a larger mass. And because he has a larger mass, he has a larger momentum. Now, all moving objects have momentum. It is a measure of how difficult it is to stop a moving object. If you need to take that down, take a few minutes and pause the video. Now, we learnt that the larger the mass of an object, the larger its momentum. But what about in this case? Which car has a greater momentum? Or in other words, which car would be harder to stop? The car moving at 105 kilometers an hour? Or the car moving at 100 kilometers an hour? Because the car on top is moving faster, this car would be harder to stop, and this car would have a greater momentum. So, which of these variables does momentum not depend on? We have velocity, time, and mass. Think about it for a few seconds. The answer is definitely time. The greater the mass of an object, and the greater its velocity, the more momentum it will have, and the more difficult it will be to stop. The momentum of an object is independent of time. So, based on that, we have this equation. Momentum is equal to mass times velocity. Momentum can be given by capital P, mass by m, and velocity, as we know, by v. And if we go further, we know that unit for mass is kilograms. The unit for velocity is meters per second. And if we simply multiply these two units together, just as we do with mass and velocity, we will have the unit for momentum, which is kilogram meters per second. Take a moment to take that down and pause the video. Now, why is momentum considered a vector quantity? This is a really important idea to understand, and it is often asked in your exams. Take a moment to think about this. The reason is, it's because velocity is a vector. As velocity has direction, the momentum of an object will also have direction. As velocity is a vector, momentum is also a vector. If an object has a velocity in a certain direction, it will also have momentum in that same direction. So let's go back to our equation and practice using this question. An aircraft has a mass of 1 million kilograms and a velocity of 15 meters per second. What is its momentum? So they've asked us to calculate momentum. They've given us the mass of 1,000,000 kilograms and the velocity of 15 meters per second. So our equation is momentum is mass times velocity. We know that velocity is 15 meters per second. Our mass is 1,000,000 kilograms. Therefore, our momentum is 15 times 1,000,000, which is 15 million. So this answer is almost perfect, but not quite, because we're missing the unit. And we know that the unit for momentum is kilogram meters per second. Let's try a few more. Now in this question, we're asked to calculate momentum. We're provided with mass and velocity. Have a go and pause the video. Great. Now that you've paused the video, let's try it together. Now, there's a trick in this question, and you may have caught it. We know that mass is measured in kilograms. However, in this question, it's measured in grams. So we need to convert 200 grams into kilograms. And that is actually 0.2 kilograms. So our first step is to write the equation. Momentum is equal to mass times velocity. In this question, mass is not 200 grams, but 0.2 kilograms. And our velocity value is 2 meters per second. So our momentum of our snooker ball can be found by multiplying 2 meters per second by 0.2 kilograms. Now, this isn't maths, so feel free to use a calculator. Our momentum is equal to 0.4 kilograms meters per second. So our answer is B. Let's try another one. Pause the video and read the question. Great. Now, in this question, our momentum is 50,000 kilogram meters per second, and our velocity is 20 meters per second. And we need to calculate the mass. Now again, it's the same process. We write the equation. Momentum is equal to mass times velocity. So we know momentum is 50,000 kilogram meters per second. Our mass, we don't know that, so we'll just write m. And velocity is 20 meters per second. So in this case, we need to do the inverse to find m. So we divide by 20 on both sides. So 50,000 divided by 20 is equal to mass. Now, you can absolutely use your calculator, and you can find out that mass is equal to 2,500 kilograms. So our answer is C. What about this one? Pause the video and have a go. Let's go through it together. In this case, we need to calculate velocity. We're provided with momentum as well as mass. So, the first step again. Momentum is equal to mass times velocity. Our value for momentum is 140 kilogram meters per second. Our mass, 70 kilograms, and our velocity is unknown. Similar to the previous question, we divide by 70 on both sides. And we have 140 divided by 70 equal to velocity. Once again, it's absolutely fine to use your calculator. And velocity we can find is equal to 2 meters per second. So our answer is A. One last one. In this question, what is the total momentum? Pause the video and have a go. In this question, we have two objects, and we need to find the total momentum of the system, the total momentum of both objects together. Let's call this object object A, and this object object B. So first, let's find the momentum of object A. So for object A, momentum is mass times velocity, and that's for object A. So our momentum of A is equal to 2 kilograms times the velocity of 1.2 meters per second. So the momentum of A is equal to 2.4 kilogram meters per second. Now, let's have a look at object B. The momentum of object B is equal to the mass of B times the velocity of B. Now, we can see that the mass of B is 1 kilogram. However, there's no indication as to its velocity. It seems to be standing still. So its velocity is 0 meters per second. Now, if we use our calculator, we can see that the momentum of B is now equal to 0 kilogram meters per second, because it's not moving, it doesn't have momentum. Remember, for an object to have momentum, it must have both mass and velocity. Great. Now that we have the momentum of A and the momentum of B, we can find the total momentum. So our total momentum is equal to the momentum of A plus the momentum of B, and that's equal to 2.4 kilogram meters per second plus 0, which is equal to 2.4 kilogram meters per second. So our final answer is C. Fantastic. Now, have a go yourself. These questions are all Edexcel exam questions. When you complete it, make sure you follow all the steps. Good luck.